Let's go to page 605 and let's do number 1. Here you want to evaluate cosine of 15 degrees. This lesson is on the sum and the difference identity, so you need to go and use sum and the difference. So you need to find out the sum and the difference of two angles that will give you the 15 using the spatial angles. So you can use any combination of 30, 45, and 60s. So this one will equal to, for example, would be 60 minus 45. Okay, so this would be example, or you can use 45 minus 30. So it doesn't matter, as long as you find the combination of the spatial angles that will give you the 15. Okay, then after you do that, then you do the expansion. You apply the difference identity. So you're going to get cosine of 60 degrees, cosine of 45 degrees, plus sine of 60 degrees, sine of 45 degrees. And from here you need to go and draw your spatial triangles. So 60 degrees. So you need one triangle for the 60 degrees. So this will be 1, 2, square root of 3. You need to get a second triangle for the 45, 45 triangle. So again, you can do the square root of 2 over 2, square root of 2 over 2, 1. Okay. So from here you can go and substitute. So cosine of 60 is this over there, so it would be 1/2. Cosine of 45 is this over there, so it would be square root of 2 over 2. Sine of 60 is this over there, so it would be square root of 3 over 2. Sine of 45 is this over this, so it would be square root of 2 over 2. So from here, you can just go and simplify, so you got square root of 2 over 4 plus square root of 6 over 4. Okay, let's go to number 3. You have sine of 105 degrees. So this one, you need to go and find a combination that will give you that. So you can use 60 plus 45. And then you do the expansion. So this is equal to sine of 60 cosine of 45 plus sine of 45 cosine of 60 degrees. You can draw your triangle, and since we already have this from the previous problem, we can just use those triangles. So sine of 60 is going to be square root of 3 over 2 by using this. So sine is vertical over hypotenuse. Cosine 45 degrees will give you square root of 2 over 2. Sine of 45 is square root of 2 over 2. Cosine of 60 is 1 over 2. Again, using those two triangles. And go and work it out. So you got square root of 6 over 4 plus square root of 2 over 4. Okay, let's go to number 5. You have cosine of 195 degrees. So you can break this down into two angles. So this is equal to cosine of 150 plus 45 degrees. So again, one of the angles you want to get all the spatial angles. Okay. Then after that, you're going to expand. So you're going to get cosine of 150, cosine of 45, minus sine of 150, sine of 45. So from here, you go and draw your triangle. So you need to have 150 and 45. So 150 is going to be right over here, which will give you 30 over here. So you're going to get 1, 2, square root of 3, and it's going to be a negative, right? So watch for that. And you need a triangle for the 45, 45. Okay. Now, if you don't like the square root of 2 over 2, then what you can do is you can use 1, 1 square root of 2. So be flexible, but you need to know your spatial triangles. Okay, so when you evaluate cosine of 150, cosine is this over there, so it would be negative square root of 3 over 1. Cosine of 45 is this over that, and when you simplify, you get square root of 2 over 2. Sine of 150 is this over there, so it would be 1 over 2. And sine 45 is this over there, and when you simplify, you get square root of 2 over 2. And when you work it out, you're going to get negative square root of 6 over, oh wait, this is 2. is this over this. Cosine is this over that, so it's square root 3 over 2. So when you multiply, you get negative square root 6 over 4 minus square root of 2 over 4. Okay. Again, notice that the reason I know that this is something wrong is because they have to have a common denominator. So when I have a 1, this will give me a 2 and this will give me a 4. So that's how I notice something is wrong. So I go back and check and I notice, okay, this is supposed to be a 2, not 1. Okay. Again, when you're doing this, it will always have a common denominator. If not, then it means you're doing something wrong. Okay, let's go to number 7. The 7 is kind of going backward. Okay, so instead of expanding the identity, you need to contract the identities. So you have cosine of 25 degrees, cosine of 35 degrees, minus sine of 25 degrees, sine of 35 degrees. So if you contract, this is equal to cosine of 25 degrees plus 35 degrees. Okay, so this is a reverse of the difference identity. And this difference of this would be the reverse of the sum identity. Okay, so this came from sum identity. From here, this is going to equal to cosine of 60 degrees. And if you draw your triangle, it's 1, 2, square root of 3. So cosine of the 60, so cosine of 60 degrees is going to be 1 over 2. Okay. Okay. So actually, these are two parts. First, you need to find a single function for that, and then give the exact answer. So this is the first part. This is the second part. Okay, number 9. You have sine of 100 degrees, cosine of 50 degrees, plus cosine of 100 degrees, sine of 50 degrees. Okay, so this is equal to sine of, so this came from the sum identity for sine. So this will equal to sine of 100 degrees plus 50 degrees. So this is equal to sine of 150 degrees. So that's one of your answer. And when you draw these things out, 150 degrees will give you reference angle of 30 degrees over here. So this will give you 30, 60 special triangle. So it will be 1, 2, square root of 3, negative. So sine is vertical over hypotenuse. So this is equal to 1/2. Yeah, let's go to 11. Yeah, cosine of pi over 3. Cosine of pi over 12 plus sine of pi over 3, sine of pi over 12. Okay, so this came from cosine difference identity. So this is equal to cosine of pi over 3. Now watch where the parentheses is supposed to go. Okay, so minus pi over 12. So this is equal to cosine of 3 pi. Well, if you make into common denominator, you're going to get 4 pi over 12 minus pi over 12. And this will equal to cosine of 3 pi over 12. And then if you simplify, this will equal to cosine of pi over 4. So this is one of your answer. And pi over 4, when you draw your triangle, that's a 45 degree special triangle. So you're going to get 1 square root of 2. So cosine is this over that, and so 1 over square root of 2, when you simplify, you get square root of 2 over 2. Okay, let's go to number 13. Okay, you got sine of 2 theta, cosine of theta, minus cosine of 2 theta, sine of theta. So this came from the difference identity for the sine. So this is equal to sine of 2 theta minus 1 theta. So this will equal to sine of 1 theta, and that's it. And since they don't give you any number to evaluate, so you cannot come with a number, so that's it for number 13. Okay, let's go to number 15. Okay, number 15, you're doing the proof. Okay, so you start with sine of pi minus theta equal to sine theta. Now when you're doing a proof, you want to keep one side the same, and you want to modify, you want to simplify the other side. So you want to keep the side as simple, the same. The one is more complicated, that's the one you want to kind of change. So you want to keep this side the same, so you want to change this one. So you just apply the sign difference identity. So you're going to get, again, try to not have your equal sign if you can. So you're going to get sine pi cosine theta minus sine theta cosine pi equal to sine theta. Now over here, you can evaluate this one. You have pi is 180 degrees, so it's right over here. Okay, so it's going to be right over here. So sine is a vertical. So in this case, vertical is equal to 0. And cosine is equal to -1. So again, you're going to get horizontal equal to -1 and radius equal to 1 and the horizontal. So okay, I'm going to call h the horizontal and the vertical is going to equal to 0. Okay, so again, because again, think of it as in terms of a triangle. Okay, so cosine of pi is horizontal over hypotenuse, so it's going to get -1 over 1. And when you simplify, 0 times something equal to 0, and negative times negative equal positive. So you got sine theta equal to sine theta. And when both sides are identical, you put a check mark, and that's your proof. Okay, okay, let's go to 17. Okay, you have cosine of pi over 2 plus x equal to negative sine of x. Okay, so again, this side is more simple, so you want to keep this side the same. You want to expand this. So this side, you use your cosine identity for the sum. So cosine of pi over 2, cosine of x, then you're going to minus sine of pi over 2, sine of x. So again, you have to keep one side the same. Now pi over 2, again, if you draw your triangle, pi over 2 is 90 degrees, so it's going to be right over here. So in this case, the radius is equal to 1, which is a hypotenuse, right, if you draw a circle. The vertical is equal to 1, horizontal equal to 0. Okay? So now when you start to evaluate, cosine is horizontal, so it's going to give you 0. Sine is going to be vertical over hypotenuse, so equal to 1 over 1. So when you multiply, this will give you 0, and this will give you negative sine x. And this side you just follow through. And when both sides are identical, you put a check mark. Okay, and that's it for number 17. Okay, let's go to 19. Okay, you got sine of 270 degrees minus x is equal to negative cosine of x. So you can keep this side the same. You want to expand that. So you're going to get sine of 270 degrees. Sine, and you're going to get cosine of x. And you're going to get minus sine of x, cosine of 270 degrees equal to negative cosine x. Okay. Now your next step is go ahead and draw your triangle. Okay, in this case it's 270 degrees, so it's going to be right over here. Okay, so in this case your hypotenuse radius equal to 1. Remember, hypotenuse is always positive, right? Your vertical is going to be -1. Your horizontal equal to 0. Okay, so you can let your vertical, horizontal, and the radius. Okay, which is a hypotenuse. So you're going to substitute. So sine is vertical, so it'd be -1 over 1. Cosine of x, you just keep the same. Sine of x, so sine, okay, so you're going to get sine x. Now cosine of 270 is equal to 0 over 1, so give you 0. Now go and work it out. So this will give you negative cosine x, 0 times whatever is 0, so it's gone. And both sides are the same, so you put a check mark and that's it. Okay, let's go to 21. Okay, you got sine of pi over 6 plus theta plus sine of pi over 6 or pi over 6 minus theta equal to cosine theta. Again, this is more complicated, so you want to go and expand these and simplify these. So you can use your identity. So you're going to get sine pi over 6 cosine theta, okay, and plus sine theta cosine of pi over 6. So this is for this one here. Plus this one over here, you're going to get sine pi over 6 cosine theta minus sine theta cosine pi over 6 equal to cosine theta. Okay. Now, when you check, right, notice that these two are identical. Okay, so these two are identical, so this will cancel out. And pi over 6 is 30 degrees. So if you draw your triangle, it's going to be like this. So 1, 2, square root of 3. So sine of pi over 6 is 1/2. So you're going to get 1/2 cosine theta. So this cancels out already. Plus, again, this is 1/2 cosine theta equal to cosine theta. So 1/2 plus 1/2 is 1. Right? So you're going to get 1 cosine theta. So you're going to get cosine theta equal to cosine theta. And put check mark. Okay, let's go to 23. Okay. So you have sine of alpha plus beta over cosine alpha cosine beta equal to tangent alpha plus tangent beta. Now this side is more complicated because you got two functions inside. All this has only one function, so you want to simplify this side. Okay, so go and expand this using the sum identity for sine. So you're going to get sine alpha cosine beta plus sine beta cosine alpha over cosine alpha cosine beta equal to tangent alpha tangent beta. Okay, now notice plus. Okay, notice there are two terms over here. So what you want to do, you want to separate the two parts. Okay, so separate these. So you're going to get sine alpha cosine beta over cosine alpha cosine beta plus sine beta cosine alpha over cosine alpha cosine beta equal to tangent alpha plus tangent beta. So go and separate so you can match what's on this. So you have to look at what's on the other side to get a clue. Okay. So from here, this will cancel out. So sine alpha over cosine alpha, so sine over cosine going to give you tangent. Okay. This one over here, the alpha and alpha cancel out. So you got sine over cosine beta, so this will give you tangent beta. And they're the same, so check, and that's it. Okay, let's go to 25. Okay, you got cosine of alpha plus beta. So this is very similar to the one above, over cosine alpha cosine beta equal to 1 minus tangent alpha tangent beta. Okay, so again, these are two functions, so this is more complicated. So you want to change this side and keep this side the same. So you can expand that. So you're going to get cosine alpha cosine beta minus sine alpha, sine beta, over, now I'm going to separate the two already, okay, so I'm going to separate this, okay, so I'm going to get cosine alpha, cosine beta, cosine alpha, cosine beta, okay, so I'm undoing the common denominator. Okay, so what I did is I go straight from here to here, right? That's what I'm doing. Again, now you can go and cancel things out. Notice it's cancel, cancel. Okay? When you cancel, it's 1, right? So that's how. So here you get 1. This one over here, this one doesn't cancel anything, but this over here, that's your tangent alpha. This over here, that's your tangent beta. And now they are same, so check mark and you're done. Okay, let's go to number 27. You have 2 sine alpha, sine beta equal to cosine alpha minus beta minus cosine alpha plus beta. Okay, so again, these are 2 functions, so this is more complicated. So I want to simplify this. I want to keep this side the same. So when I expand that, I get cosine alpha, cosine beta plus sine alpha, sine beta. So this whole thing is the first one. Now you have to be careful now because it's a minus. So I'm going to put parentheses, I'm going to do this, okay? So put a parentheses, okay? So cosine A plus B or alpha plus beta, you're going to get cosine alpha, cosine beta. Okay, now this is plus will become minus, and then it will give you sine alpha, sine beta. Okay. Now I'm going to get rid of parentheses by changing the sign. So I get cosine alpha, cosine beta plus sine alpha, sine beta. Now this becomes minus cosine alpha, cosine beta. Now minus minus become plus, right? So I get sine alpha, sine beta. The next is I'm going to look for the like terms. So this one and this one cancel out. And these two are the same, so when you have this plus, you get 2 of them. So this plus, you're going to get 2 sine alpha, sine beta, and this side original is 2 sine alpha, sine beta, and they're the same, so you're done. Okay, let's go to number 29. You have 2 cosine alpha, cosine beta equal to cosine alpha minus beta plus cosine alpha plus beta. They all look very similar. Okay. So again, this is more complicated than these, so you want to keep this side the same and you want to modify these. Okay, so you got 2 cosine alpha, cosine beta equal to, so to expand that, you're going to get cosine alpha, cosine beta plus sine alpha, sine beta. So this is from the first one. Okay, plus, well, actually you don't need a parenthesis because it's a sum. So if it's subtraction, you got to put parentheses so you can change the sign. But if it's plus, you don't really need a parentheses. But anyway, so this one, you're going to get cosine alpha, cosine beta minus sine alpha, sine beta. So by looking at this, so you have plus, minus, so this one and this one they're going to cancel out. So this one and this one cancel out. And these two are the same, so when you add 2 of them together, you end up with 2 of them to be 2 cosine alpha, cosine beta. And this side you got 2 cosine alpha, cosine, beta, and they are the same, so therefore you check and you're done.